All right, so welcome to the next installment of conditional probability. So we're looking at conditional probability in the context of a discrete random variable. Here we're told that the discrete random variable x as a probability function, the probability that x equal kx. So where x goes from 1 through 6, and we're asked to solve a range of probability questions. So for this type of question, what I strongly advise you to do is to sketch out or to draw a table where x and the probability that x equal x is going to be highlighted. X goes from 1 through 6. So 1, 2, 3, 4, 5, and then 6. So we're going to apply the formula for the probability. So it will be k times x. When x is 1, we get k. When x is 2, we get 2k. When x is 3, we get 3k, and so forth. We're going to use a fundamental property of probability that the sum of the probabilities add to 1 in order to solve for k. So k plus 2k plus all the way up to 6k, that's equal to 1. So 3, 6, 10, and then 11, that's 21k. So 21k is equal to 1. Therefore, k is equal to 1 over 21. All right, so I trust that clarifies the method for solving for k. Therefore, the probability that x is equal to x, we can put it below if we want. So that's 1 over 21, 2 over 21, 3 over 21, 4 over 21, 5 over 21, and 6 over 21. I will leave it, even when there's an opportunity to simplify, I will leave the denominators the same so that it is easy to add or subtract, as may be the case. Now, in this case, they tell us to solve for the probability of A of x equals 6, given that x is greater than 3. So straight away, the given that symbol, the forward slash symbol, tells us we're dealing with conditional probability. So we're going to invoke the formula for conditional probability. It's the overlap over the restriction. So the overlap, greater than, what does it mean to be greater than 3 and equal to 6? What's the overlap between greater than 3? So we're 4, 5, 6, and equal to 6. So there's only one outcome that satisfies that, and that is being equal to 6. So the probability of being equal to 6 is 6 over 21. And then the probability of being greater than 3, it can be 4, 5, or 6. That's going to be 15 over 21. So when we do that, this simplifies to 6 over 15, and we can leave that as is. You don't have to simplify further. So for part B, solve for the probability that x is odd, given that x is prime. Again, we're going to invoke the same formula, and we're going to be looking for the overlap, and then divided by the probability of the condition or the restricted event. So the overlap will be asking us, what are the odd prime numbers? So odd prime numbers will be 3 and 5. And we again remember, of course, that 1 is not a prime number. So 3 and 5, that's going to be 8 over 21. So this is going to be equal to the probability of odd and prime over the probability of prime. So that is going to be 8 over 21 divided by the probability of prime. So to be prime means to be either 2, 3, or 5. So that's going to be 10 over 21. When we simplify that, we get 8 over 10. And if you're not comfortable with the fractions, you can always use a calculator. Again, we don't really need to simplify any further. we're not being paid any additional marks to simplify, to do any additional work. All right, so we can stop here, but hopefully this was beneficial to understand another way in which the probability information could be presented to us through a probability function and being able to cope with that presentation.